So I will get straight on to Hans van der Wies, and he'll be telling us what can we do now to improve welfare. Over to you, Hans.
Okay, thanks Mike for introducing me. This is to give you all a brief overview of the work we have been doing and what you actually can do as a company. And before I start talking about that, I give you a little bit background information on the blue transformation, how catch welfare relates to that. As you probably know, the blue transformation is a strategy of the United Nations, and to meet the growing demand in aquatic food, and also what is key is that important sustainability goals are met, like the climate change, like hunger, like solving the issue of poverty, things like that. And of course, simply increasing the production of food is not the solution. We have to be aware that biodiversity is also an important topic. I now move on to the next slide. And here you see, again, our major goal is to minimize stress, injury, thereby improve meat quality, and also increase the rate of survival in the bycatch that is released into the sea again. And it's very obvious that this relates to sustainability goal number 14, that is conserve and sustainable use of the oceans, sea and marine resources for sustainable development. So you see, the Catch Welfare Platform also relates to the Sustainable Development Goals as set by the United Nations. Okay, having said that, I now want to continue with capture and killing of fish. Well, you've seen this picture many times before, but I decided to show it once more because not everybody here has been taking part in previous meetings or our conference in Bergen last year. And you see here all the steps, the capture process, the retrieval of the fish, the handling on board, the slaughter, and of course the fish that is released into the sea again, or the fish that escaped from the net. And it's an accumulation of stressors. So it's important to keep that in mind. I need a little bit of water, one moment. Well, to give you a brief overview of the type of gears, for capturing of fish, various types of gears are used: trolled nets, purse seine nets and traps. And each of these nets can have an impact on the welfare of fish. And of course you have to consider the fishing grounds as well, the season, and the fish species, the life stage of the fish, and so on. Well, how can we start developing a novel technology or an improved technology? The first thing that needs to be done is to carry out experiments in a laboratory setting. Here, stunning is only given as an example. It's very important to do this in collaboration with research institutes. In case of stunning of fish, it boils down to registration of EGs to establish the specifications for stunning. The second step is testing the equipment under under commercial conditions or similar conditions. In case of stunning, that means that no pre-shocks, no carcass damage, and it should of course be safe for the crew on board the vessel. But of course, this approach also applies to a new fishing gear that's being developed. That means do the experiments in a flume tank before you test the gear on board or at sea, I mean. I move on now to the next slide. And of course, the next step is, as soon as the new technology or the improved technology has been implemented in practice, you have to think about how to ensure that everything is functioning well. Then you need to have good manufacturing practices in place. You need to have trained staff. And of course, a quality assurance system needs to be in place to ensure a sound implementation of the technology. And to give you a little bit background information, what's the difference between quality assurance and quality control? Well, quality control is actually the end product quality, testing of the end of the product, at the end of the chain. Quality assurance is focused on prevention and controlling critical steps. So really, quality assurance is the way to go. Some way, I think the slide is lost. Okay, it's there again. Thanks. Okay, to give you a little bit background information about quality assurance. You have to start with a multidisciplinary team and think about, okay, we need a plan. That means, what kind of manufacturer do I need? Is there a research institute I can collaborate with? What are the costs? This is the first thing you have to do. And then the next step is, okay, make a flow chart of the current process. Make sure that you really know what is happening in practice. Then conduct a hazard analysis of the welfare aspects, like we are also doing in this catch welfare platform. You also need to know the critical steps in the process. Which steps really need to be controlled? What kind of limits do you use or target levels do you use to make sure that indeed you control these critical steps? And also, that's very important, make sure that you have sound monitoring procedures in place, and you can use operational welfare indicators for that. Okay, I move on to the next slide. This is also important to be aware of. For the critical limits, you need a three-class system. What you actually want to have is to have an operational limit and of course a critical limit. Imagine that during crowding, the oxygen levels of the water become way too low. You want to have a limit that gives you a warning, and that's an operational limit, let's say 50%, and the critical limit is 40%, that when you reach the 50% level, you still have time to take action. That's rationale. And this to show you a little bit information about crowding. This is the way it has been done in an experiment in Norway, and Mike Breen provided me with this slide. This is a monitoring system. A 360 degrees camera was used to monitor how the fish was behaving, and also measurements were done in a net during crowding. I show you the next slide now. And you see here in the behavior, using a camera, how the fish behave during low crowding to high crowding. You see that you see big differences in the behavior of the animal. So this can be a way to monitor the effect of crowding. Okay, one last slide on crowding. You see the black line, that is related to crowding. The blue line is the oxygen levels, and the behavior goes from an ordered to a disordered state due to the effect of crowding. And of course the oxygen levels drop when the crowding is very intense. And here is an example as it is used in aquaculture to monitor crowding. You can do it on an individual level, you can do it on a group-based level, or it can be done on an environmental level. That means monitoring of oxygen levels in the water, for instance, but also loss of scales. If there is blood loss in the water turns red. That will tell you something about the effect of crowding and how it is really going. Is it really overtaxing the animal, or is it really done in a mild way? The next thing that's also very important, that's the modular harvesting system, to avoid that when the fish is brought on board that there is huge compression in the cod end, and this is a sack with water filled, so when the fish is lifted, when the net is lifted, there's no compression, and it really has got a big impact in a positive way on the animal, less damage to the animal, and that means better welfare. And here you see some of the pictures, a comparison between the traditional mesh cod end and the Flomo cod end, or the the modular harvesting system. And this is a picture that shows the impact on the product quality. There's a huge difference between the product quality. The product quality as it is obtained with the modular harvest system is really superior compared to the mesh cod end. So these are clear examples how animal welfare can be improved, and also how product quality can be preserved as best as possible. Just some words about stunning and killing of fish on board. This is an experiment we've done, I think, almost 14 years ago. Here, cod and haddock were captured by an otter trawl during winter. The animals were stored in a dry bin on board, and we monitored the animals for 2 hours. We observed in cod, even after 2 hours, that we could still measure a normal EEG. That is labeled as C4. After storage of 2 hours in haddock, we also could measure still a normal EEG. The amplitude of the signal was a little bit suppressed compared to the animal that was stored for less than half an hour, but nevertheless it was still a normal EEG. So this really shows that it makes sense to stun both species when they are captured with an otter trawl. I move on now to the next slide. Just to repeat once more, if you want to put stunning of fish into practice, follow these 2 steps. Carry out experiments in a laboratory setting, use EEGs to register that the animals are indeed unconscious without recovery, then test in a commercial setting if the specifications can be met, and of course the equipment should be safe to use. And another important aspect is that the slaughter rate that is wished for by the crew on board is achieved. This is just an example how an experiment in a laboratory setting is carried out. Here you see a place laying on a kind of grid that drains, and 2 water jets are touching the fish. One water jet is the plus electrode, and the other water jet is the minus electrode. And by doing this, by testing this, we've observed that we can save a lot of energy, but the very big advantage is that it leads to a little bit increase of the temperature in the brains, and that kills the fish. So this is a big improvement. We can stun and kill fish using electricity in one step. And this concept has been conceived by Robin McKim, and he applied a patent on this. So, and we are now discussing with Optimar how we can put this into practice. We have made a preliminary design of what the equipment can look like, but we are busy to change that now, so I cannot show you this. But this is the way I think we can put electrical stunning of captured flatfish into practice. Okay, some final remarks. Of course, a company should benefit from good welfare practices. Incentives are important. And of course, product quality is also an important thing we need to consider. An improved outdoor appearance is very important. Shelf life, if it can be increased, that should be achieved. Of course, drip loss is reduced when we improve quality, and less damage to the catch that is released into the sea is very, very important for sustainability of fisheries. Thank you for your attention.
Thank you very much, Hans. Michelle, do we have any questions from the audience?
One moment. I don't see anything yet here.
No, it should be there. Well, one from Doug. According to my experience with aquaculture producers in Europe, there is often a disconnect between research priorities and practical priorities. The connection between research and industry in this platform is a huge strength. Well, that's more a compliment than it is a question, I think.
Yes.
Thank you very much, Doug. It was
Yes.
nice to hear it anyway.
The rest was about the surveys. So,
Yes.
no.
Okay.
So we can move on to the
Yep.
next.